Hello, hello, and welcome to BC Calculus with Henry Lambino. Alright, we're going to be looking at 13.3 today. That is the dot product, which is essentially this right here. All this stuff in the square, basically the dot product of a vector v and w equals the magnitude of v times the magnitude of w times the cosine of theta, theta being the degree between those two vectors, and the other definition of it is the dot product of v and w equals v1 times w1 plus v2 times w2 plus v3 times w3, where, as you can see down here, v1 and w1 and v2, w2, v3, w3 are the different scalars of the i's and j's in those vectors. So in this problem we're mostly going to be using this right here, which is the algebraic definition of vectors. So let's look at that. All right, so this is problem number 22 over here. Right here, it's in 3 parts, so this is going to be a bit of a longer video. So the first part is we have to find a component of f parallel to v. Okay, I'm going to try to zoom a little bit over here. Okay, here we go. So find a component of f parallel to v. So I drew a nice little diagram. So we have our vector v here, which is this vector right here, and then we have our vector our force f here, and we're trying to find f par. I put it at f par. It stands for f parallel, and f perp. I put it as f perpendicular. That's A and B, parts A and B, and then we'll get to work, and I'll discuss that later. So the way we're going to do that is we're going to set up some truths that we know, and then we're going to try to solve for that. So what do we know? So yeah, I'll solve for that. Okay. So we know that let me go down a little bit. We know that vector f is going to be equal to f par plus f perp, just by the nature of because they create a triangle. That's just the nature of their sin. So we know that, and we also know, and if we're trying to find x parallel, we know that the magnitude of f parallel is equal to f times v dot product of f times v all over the magnitude of v. So these are our two truths that we know. So those are our two truths that we need to know. And so what we're trying to find in here is if we're trying to find the component of f parallel, what does f parallel consist of? Well, it consists of, we need to find the magnitude, and we need to find the direction, because those are the two parts of the vector. So how do we find those? Well, let's first find the direction. The direction is going to actually be the same as the direction of vector v up here. It's going to be the exact same direction as that vector. However, it's just not going to have the same magnitude. So how do we do that? Well, we need to find a scalar for that, and find the scalar for the unit vector of v, which because the magnitude of unit vector is 1, and then we can multiply it by a scalar to get the actual vector that we need. So in the end, from that we know that f parallel is going to be equal to some scalar x times v unit, or the v unit vector. So let's solve for this. So the v unit vectors. All right. So what's the v unit vector? v unit is going to be equal to, by definition, v over v. So we're going to solve that out. So we know v equals, what is it? 3i plus 4j. Oh god. Okay. 3i plus 4j. Okay. And to find the magnitude, which then we need to divide that by the magnitude. So we're gonna do 3 squared plus 4 squared, square root of the third. So 4 squared, which is going to equal square root of 9 plus 16, which is going to equal the square root of 5. The square root of 25, which is going to equal 5. So our unit vector. We just solved that. So we know that our v unit vector is going to equal 3i plus 4j all over 5. And so we just found the unit vector. Now, so that is our direction of our f parallel. So that's a direction. So now we have to find our magnitude. Well, the magnitude of that. Well, we have this equation up here for finding the magnitude. So we have f parallel. Magnitude of f parallel is going to be equal to the dot product of f times the unit vector. I'm just going to take out the unit vector of that. So that's what that is. So let's solve that out. We have f equals negative 3i minus 5j, negative 3i minus 5j. So we're gonna want this is going to be negative 3, negative 5 times, and if we go up here, this is going to be if we go back to the v unit vector, it's going to be 3, 5, comma 3, 4. And now we're going to solve that out, and we get we're going to solve that out using if we go back up here, the dot product rule. Remember this. We're going to use this right here to solve this problem, to solve this right here. So let's do that out right now. So when you do that out, you get negative 29 over 5. And that is our magnitude of f of f par. So now we have both the magnitude and we have the direction. So we basically have all the different parts of f par, I'm sorry, to put together. So we have x par equals f, the magnitude of f par times the unit vector, and so that is going to equal oh god, so that's going to equal negative 29 over 5. That's such a bad number. Times 3i plus 4j over 5. Alright, and then you just need to distribute that out, and it becomes really ugly and evil. But that is essentially a problem. So we just basically found the two parts of it and solved, and yeah, now it's all good. Now we found both the magnitude and the direction of f par, and thus we were able to put it all together and create a nice problem. All right, so now on to B. So now we're going to go and find B, which is we have to find the component of f perpendicular to V. And you might think, oh wait, oh man, we have to go through that whole process all over again. Oh, how horrible. No, actually, we don't, because if you notice right here, we can solve actually for f perp. We have this equation right here to solve for that. F equals vector f equals vector f par plus vector f perp. So we can actually solve pretty easily for f perpendicular. So we're going to have if vector f equals vector f par plus vector x perp. We can solve for f perp, so f perpendicular equals f par. Oh, I'm sorry. No. Equals just vector f. Oh my god. Vector f minus vector f par. So now we can just plug and chug and figure that out. So eventually, after doing a bunch of evil math, you'll come up with the vector f perp equals negative 72i minus 91j over 5, and that is so horrible that I couldn't subject you guys to watching me do out all the algebra in that. So I just did it for you. So so that's part B. So now we're going to move on to part C, which deals with work. So for problem C, it asks us for the work. Let's find the specific word. Find the work W done by force F, force vector F through displacement V. So this is actually nice. So that sounds really weird and horrible, but it's actually quite simple, because work equals force times distance. That's what work equals. So this problem is just giving us the force distances. We have obviously our vector F, so our work W. We have obviously our vector F, and then times our distance, which it gives us as vector V. So this is just a dot product between F and V. So it's actually really not that bad. So then you solve this out, and I'll do that right now. Okay, so that's after doing all the workout. So so this is just using dot product once more. It's using the algebraic dot product, which states that V dot product V and W equals V1 times W1 plus V2 times W2 plus V3 times W3. So that's just that dot product rule, and you can see as you go through here, we have the different -3, -5 from the F by the dot product of 3 to 4. Multiply them out. You plug it in here, and then you solve it out algebraically until you get your answer of -29, and that's your work for the problem. All right, so that's a basic overview of the dot product and how you can use it to find vectors and their resulting vectors from two vectors. So it's actually a really fun tool, and while it can be a little bit confusing, it is really fun. All right, hope you guys enjoyed that, and I'll see you guys next time.